Hello, my name is Patricia Bueno. I am a professor at Pontificia Universidad Católica del Perú, and I'm going to present the work Evolution of the Application of an Educational Innovation in a General Chemistry Course. Currently, the concept of educational innovation is closely linked to the quality of higher education and generally refers to the planned process that lead to further improvements in the educational context, according to their characteristics and objectives. Thus, a variety of strategies has been reported to improve student learning in which the learner has the central role. However, not necessarily the results are as expected, because the teaching-learning process involves a complex set of relationships between three major dimensions: characteristics of students, teaching, and institutions. All of them exert direct influence on the quality of achieved learning. This study discusses the evolution of the implementation of a hybrid PBL approach in general chemistry courses for engineering students at a Peruvian university. This implementation was started in 2002, and the context in which it developed had some changes that influenced the achievements in some aspects involved in the methodology, such as motivation, skills for problem solving, and critical thinking. Problem-based learning has had a major impact on higher education, and particularly in engineering education. In this context, between the years 2002 and 2004, the problem-based learning in Peruvian higher education project was developed with participation of the Institute for Transforming Undergraduate Education of University of Delaware. The project's main objective was to incorporate the PBL methodology in science and engineering teaching practices of the Peruvian University and, indirectly, to promote this methodology in other local and regional institutions. Mosby has proposed a four-step process to implement a new educational model as PBL. In the case of Peruvian University, this process was performed as shown in the figure. The preliminary activities involved the formation of a commission of pedagogical modernization, promotion of opportunities for reflection and discussion about university teaching practice, organization of some visits to American and European universities. The adoption stage involved coordination with University of Delaware to establish the cooperation agreement. Some professors were selected to assume the role of change leaders, and the leaders training in University of Delaware. The implementation stage involved round development of teacher training programs, monitoring and evaluation of the experience, performing of a hybrid PBL approach in isolated courses of science and engineering curriculum. The experience failed to achieve the state of institutionalization. The implementation continues only in some isolated courses. General chemistry courses are the most representative. Over time, the context in which the implementation is carried has suffered important changes that cause the loss of sustainability. Some of these were resistance to change of professors and students, policy changes of the authorities in charge of the academic unit, and the characteristics of students, who currently show a greater degree of immaturity, some weaknesses in their prior knowledge, and no experience in self-learning. In this study, different cohorts of first-year engineering students were considered, Each one was enrolled in a general chemistry course in a different semester. Table 1 summarizes the group's characteristics. 3 instruments were used in this study. Each one assessed different dimensions of the corresponding construct. These instruments were Attributional Achievement Motivation Modified Scale, Penk-Result Test to assess critical thinking skills, and Knowledge Structure Tests. Figure 1 shows the dimensional profile of achievement motivation, expressed as maximum score percentage in each dimension for each participant group. The 3 participating groups showed similar results in which the dimensions interest and effort and collaborative interaction with peers were those with the highest score and differed significantly from the other, according to the results of ANOVA. These results show that, despite the difficulties arising in the implementation context over time, the student was engaged in a process wherein the challenge of the task complexity and the collaborative interaction with peers were equivalent to the interest and effort that students made to reach learning objectives and together represent aspects that contributed to increased motivation. Figure 2 shows the Penk-Result dimensional profile and total score, expressed as maximum score percentage in each dimension for each participant group. Total score for the 3 groups was quite low, which shows that the critical thinking skills have not had the expected development in the implementation. The 3 groups showed similar dimensional profiles. Problem-solving dimension achieved the highest score and differed significantly from the other according to the results of ANOVA. This result was not surprising since the skills for problem solving are promoted with greater emphasis on science education. The application of high-grade PBL models with students who have no experience in self-learning implies that scenarios and processes designs have a high level of control and scaffolding that somehow limits the development of argumentation and making decision skills, which are important components of critical thinking. Figure 3 shows the results for each level of knowledge structure expressed as maximum score percentage for each test applied and each participant group. In recent years, our students have shown some weaknesses in their previous knowledge and experience for self-learning. This makes the learning process more difficult for them in a context in which it is intended that the learner assume the leading role. This was evident in the low scores achieved by G3 group in the concepts level, which were significantly different from the other groups in thermodynamics and chemical equilibrium tests, both topics especially difficult for students. G1 group corresponds to a more favorable implementation environment, and so that this group had higher scores in the principles level, which were significantly different from the other groups in thermodynamics and kinetics tests. The third level is of particular interest to assess progress in hybrid PBL implementation, as it is expected that students develop skills to apply the concepts and principles learned in new situations. The results show that G1 group had better scores in this level, which were significantly different in thermodynamics and chemical equilibrium tests. The growing academic weakness of G2 and G3 groups made necessary the use of more structured designs for scenarios and processes, so opportunities for deeply and meaningful learning were limited. Despite the limitations during the reported hybrid PBL implementation in an isolated course from a predominantly traditional curriculum, the motivational profile of students from an attributional perspective has been favorable, as the most positive attributes for learning prevail, such as interest and effort and collaborative interaction with peers. The weaknesses of a student academic profile are frequently the reasons that explain the use of more structured scenarios and processes and a higher level of professor control. This has negative effects on the development of critical thinking skills and particularly to the level of application of knowledge to new situations. However, if these risks are known, faculty could take the challenge of incorporating new elements to their teaching strategies so that these limitations can be overcome to some extent, and it could be possible to achieve improvements in the quality of student learning, as this is the main goal of our role. Thank you.